Hello, my name is Kevin Treader, product marketer with Microchip Technologies Analog Division. In a previous Amplitude series, we explored the term rail-to-rail as it applies to the input stage of an operational amplifier. This episode will focus on the same concept, but as the term rail-to-rail applies to the output stage of an amplifier. Now, as the name implies, rail-to-rail output indicates that the output voltage range of the amplifier can span one supply rail to the other. This ability is a function of the design of the output stage of the amplifier and is also dependent on the loading conditions. For the purposes of this discussion, we will focus on amplifiers that implement a CMOS output stage, as shown here. An output stage that is implemented with complementary CMOS FETs is limited in terms of the output voltage range due to the on resistance of the transistors. The output voltage swing will be reduced by the IR drop across these internal transistors. So how close to the supply rails can a given amplifier output swing? Well, this specification can be found in the amplifier datasheet and is typically noted as VOH and VOL, which stands for the high level and the low level output voltage respectively. Let's take a look at an example. The MCP 6421 CMOS op-amp from Microchip claims rail-to-rail input and output performance. Here's the specification table that highlights the VOH and VOL. The typical specification at 5.5 volts is plus or minus 1 millivolt within the positive and negative supply rail, as illustrated here. I mentioned earlier that the output voltage swing of the amplifier is also dependent on the output loading condition, namely the amount of current that the op-amp must source. The specification for VOH and VOL, shown for the MCP 6421, are specified with a 100 kiloohm load resistor to mid-supply. Hence, the amplifier is supplying very little current in this case. As the output current increases, the IR drop across the internal output transistor goes up, limiting the output voltage swing. This characteristic is shown here for the MCP 6421 operational amplifier. At low output current levels, the output voltage is within a millivolt of the supply rails. However, if required to source 10 milliamps of current, the output voltage range is restricted to approximately 300 millivolts within the two supply rails. Although no amplifier can truly swing rail to rail, many can get very close, especially under light loading conditions. The output swing of an amplifier can become a critical design consideration, as it may limit the dynamic range of the system. This is especially critical with low supply voltages, where the dynamic range is already limited. Thank you for joining me for this edition of Amplitudes. For more information, please visit www.microchip.com/linear. See you next time.